Welcome to The Explainer. Today, we're looking at something that literally connects the sky above us to the biological survival of communities worldwide. We often think of global weather anomalies just in terms of, meteorology, temperature graphs, wind currents, rainfall charts, that kind of thing. But today, we're going to translate those charts into human terms. We're exploring how a massive shift in global weather patterns directly shapes and threatens human health on a truly staggering scale.
Okay, let's dive right in. This isn't just a weather event we're talking about. It's a profound humanitarian challenge. Weather patterns directly dictate the health, the safety, and the survival of millions of people. When the climate changes abruptly, the ripple effects hit the most vulnerable populations first. It transforms a simple lack of rain or a massive excess of it into an immediate life-or-death health crisis.
Which leads us to a pretty fundamental question. How exactly does a weather phenomenon thousands of miles out in the Pacific Ocean threaten the health of millions across the globe? It's this fascinating and honestly terrifying physical link between a changing climate and sudden biological outbreaks. We're going to map out exactly how atmospheric pressure and ocean temperatures translate directly into malnutrition, cholera, and malaria.
So here's our roadmap for today. First, we'll look at the 2015 to 2016 El Nino. Second, the resulting global health crisis. Third, Africa's climate emergency as ground zero. And finally, the humanitarian response.
Let's kick things off with Section 1, the 2015-2016 El Nino, a historic weather anomaly.
To really understand the health impact here, we've got to grasp the sheer magnitude of this thing. Rivaling the absolutely devastating 1997 to 1998 event, this particular El Nino acted as a massive accelerant for extreme weather, and it swung like a giant pendulum. On one side of the globe, we saw parching, devastating droughts in regions like Central America, Southern Africa, and Southeast Asia. But then, on the exact opposite side, intense, overwhelming wet conditions triggered massive floods in East Africa, Peru, and Ecuador.
And this crisis actually cascades across the seasons. Look at late 2015. Severe dry conditions set into the Americas and Africa, while simultaneously heavy rains just battered East Africa. Then, by early 2016, those extreme droughts stubbornly persisted, while sudden, intense wet conditions popped up in places like Peru and eastern China. See, the weather doesn't just change for a few days, it sustains these extreme patterns long enough to completely disrupt local ecosystems.
Moving on to Section 2, the global health crisis, from meteorology to biology.
All right, this is where we shift our focus from the sky down to the ground. Because when weather goes to extremes, local biology follows suit. It's literally a wheel of consequences, mapping out exactly how weather translates into human suffering. Think about it. Increased rains and massive floods create contaminated water and completely trash local infrastructure. That leads directly to waterborne diseases like cholera. Then flip it around. Droughts trigger widespread food insecurity and a lack of sanitation, which leads straight into severe malnutrition and communicable diseases. It is, quite literally, a perfect storm of health hazards.
I really want to emphasize this cause and effect loop. It's not just a lack of rain, right? It's the beginning of acute malnutrition, which severely weakens immune systems across the board. And a flood isn't just a puddle, it's an immediate, massive breeding ground for mosquitoes. This causes huge spikes in vector-borne diseases like malaria and dengue fever, often in areas that are completely unprepared for them. The weather creates the environment, and the diseases, they just exploit it.
Which brings us to Section 3, Africa's climate emergency, ground zero.
To see what this looks like in reality, let's zoom into the Horn of Africa. Now, before we even look at the numbers for this event, we have to note the terrifying historical precedent set by the 1997-1998 El Nino. Unusually high rainfall back then triggered massive cholera outbreaks. We're talking over 40,000 cases in Tanzania alone. And even worse, an unprecedented wave of Rift Valley fever infected nearly 90,000 people across Kenya, Somalia, and Tanzania. So this is the catastrophic baseline that health officials were staring down.
And the scale of this newer threat, it's massive. 22 million. Just let that number sink in for a second. That is the total number of vulnerable people affected by devastating drought, which was then, bizarrely, followed by unusually heavy rains in the Horn of Africa. 22 million human beings suddenly highly vulnerable to vector-borne and communicable diseases, all because of this wild weather whiplash.
So the crucial point here is that out of that wider crisis, over 10.2 million people in Ethiopia alone found themselves in need of immediate food assistance. You have to realize, this wasn't a slow, gradual shift. This was an abrupt, massive spike in severe food insecurity triggered directly by back-to-back poor crop seasons caused by El Nino. And sadly, it was a number that authorities fully expected to just keep rising.
When you break down these localized emergencies, the picture becomes startlingly clear. In Ethiopia, close to 400,000 children were left severely malnourished. Over in Somalia, 145,000 people were displaced, not by drought, but by sudden, violent floods. In South Sudan, 7.5 million people required direct relief assistance. These are not just abstract global statistics on a chart. These are specific, massive, ongoing crises requiring intense, immediate medical intervention.
All right, Section 4, the humanitarian response, the counteroffensive.
You obviously can't just react blindly to a crisis of this scale. So the World Health Organization outlined 3 distinct, proactive recommendations for regional preparedness. They were essentially trying to turn meteorological forecasts into a tactical health defense. Let's walk through each of these steps.
Step 1 is all about foresight. Assess and monitor. Basically, this means health officials must establish a direct, ongoing dialogue with national meteorological services. I mean, you have to know what the weather's doing if you want to predict what the diseases are going to do, right? This step requires conducting really localized health risk assessments in potentially affected areas, way before the full brunt of the anomaly actually hits.
Step 2 shifts things rapidly from just monitoring to taking real action. Develop strategies and activate emergency measures. This means getting actual operational capacities in place on the ground right away. We're talking about pre-positioning vital supplies like insecticide-treated bed nets for malaria and essential drugs for cholera. It's about stockpiling them exactly where the meteorological data suggests they're going to be needed the most.
Then, Step 3 connects the experts directly to the people. Develop effective communication strategies. Because, let's be honest, a huge stockpile of medicine doesn't help anyone if the public is totally unaware of the risks. This step is all about keeping the public actively informed about the climate hazards. It's managing the flow of knowledge and, frankly, loudly advocating to relevant donors to mobilize the cash and resources needed to keep the whole response running.
And we can actually anchor these recommendations with real-world actions that were taken during this crisis. The WHO deployed specialized surge staff directly to hotspots like Ethiopia, Somalia, and Tanzania. They delivered 20 rapid deployment disease surveillance kits, they call them EWARs in a box, which contain all the field-ready equipment needed to manage disease outbreaks for up to 10 million people. Incredible, right? They also launched a massive $33 million health sector appeal just for Ethiopia and issued joint disease awareness messages for major risks like Rift Valley fever.
So we've seen how a shift in ocean temperatures can literally dictate the survival of millions, translating droughts into starvation and floods into widespread epidemics. But it leaves us with a really vital question to ponder. As extreme weather events become more and more predictable thanks to modern meteorology, are we actually doing enough to predict and preemptively fund the inevitable health crises that follow? Thanks so much for joining me for this explainer. I really hope it gave you a new lens through which to view the incredible, undeniable link between our climate and our global health.